problem, I want to take a look at finding volume as a triple integral in cylindrical coordinates. So we're asked to find the volume of a sphere of radius A. I'm just going to call that my region E. Okay. And I know that the equation for that would be x squared plus y squared plus z squared is equal to a squared. It is implied by saying that a is the radius, that a is positive. You can't have a negative radius for a sphere. Okay, so I'm not specifying what the radius is, but I do know that it's a positive number. Okay, well, I know that volume would just be the triple integral over E of 1 dV, but I don't particularly feel like setting this one up in rectangular coordinates. So I'm going to switch to cylindrical coordinates instead. So if I have a sphere of radius A, as we said, this is its equation. That means that z squared is a squared minus x squared minus y squared. But in cylindrical coordinates, that would be z squared equals a squared minus r squared. So that z is plus or minus the square root of a squared minus r squared. So my bottom surface would be z is the negative square root of a squared minus r squared. My top surface would be z is the positive square root of a squared minus r squared. And if I want to be a little bit strategic here, I can realize that the volume of the whole sphere is going to be twice the volume of just the top half. Okay, so that's what I'm going to do. I'm going to say the volume is equal to twice the volume of the top half, and I'm just going to set up the integral that would give me the top half. Okay, so now I'm looking at a hemisphere of radius A. If I project that onto the xy plane, I get the same thing as if I projected the entire sphere onto the xy plane. I'm just getting a disk of radius A. Okay. But now, because I'm working with the hemisphere, I can say it 2 times because I'm just doing the top half. But now my bottom surface is 0, which is a little bit nicer than the negative square root of a squared minus r squared. So I'm going from 0 to root a squared minus r squared. And then we're integrating over this disk. So r goes from 0 to a, and theta goes from 0 to 2 pi. We were integrating 1, but remember dv becomes r. And then these were my z limits, these were my r limits, and these were my theta limits. So if I'm finding volume in cylindrical coordinates, my integrand is always going to become r, because the factor of r from the dv gets multiplied by 1, and that's what I integrate. Okay, so we've got 2 copies of the integral from 0 to pi, the integral from 0 to a. If I do this inner integral with respect to z, an antiderivative of r with respect to z is just r times z, and we're evaluating that between root a squared minus r squared and 0. Then we'll still have to integrate that dr d theta. So I'm going to have 2 times the integral from 0 to 2 pi, integral from 0 to a, r times the square root of a squared minus r squared, minus r times 0, which is just 0. So dr d theta. That extra factor of r proves to be very nice, because now I can do a u sub. I'm going to let u equal a squared minus r squared, so that du is negative 2r dr. There's the r I need for that u sub. Now I'm also going to need a factor of negative 2, which I'll counterbalance with a factor of negative 1/2 on the outside. And of course that's just going to cancel with the 2 that was already there, although I do now have a negative sign in the front. Okay. So now I've got negative integral from 0 to 2 pi, integral from the u value at 0 would be a squared minus 0, which is a squared, to the u value at a would be a squared minus a squared, which is 0. Okay. So notice we're now integrating from a bigger value to a smaller value. That's going to give us something negative, which is going to cancel with that negative. Okay. And then this just becomes u to the 1/2 du d theta. Let me erase the board and give myself a little bit more space to finish this one up. So we had negative integral 0 to 2 pi, integral a squared to 0, u to the 1/2 du d theta. If you want, you can use that negative sign, absorb it to flip this to make it from 0 to a squared. I'm just going to keep it as is. So that's negative integral 0 to 2 pi. I'm going to get 2/3 u to the 3/2 evaluated between 0 and a squared. And then we still have to integrate that with respect to theta. So that's going to be negative integral from 0 to 2 pi. When I plug in 0 for u, I get 0, minus when I plug in a squared, this has me take the square root, which is just going to be a, because I know that a is positive. So a squared to the 3/2, in general, that would be the absolute value of a cubed, but in this case I know it's just a cubed because a is positive. Okay. So that's going to give me 2/3 a cubed, and then we still have to integrate that with respect to theta. So I'm going to factor out the negative 2/3 combined with the negative that's already there. Oh, you know what? That whole thing is constant. I'm going to factor out the whole thing. So I'm going to have a negative negative, so it's 2/3 a cubed. And when I'm integrating a constant, I just get that constant times the length of the interval. The interval from 0 to 2 pi has a length of 2 pi. So that's going to give me 4 pi a cubed over 3. Now, if you know the geometric formula for the volume of a sphere, it is 4/3 pi times the radius cubed. That's what we just figured out. Now, a lot of people don't come into 3C knowing that. A lot of people leave 3C knowing that, okay? This is the sort of thing where if I gave you this problem where I said, integrate to find the volume of the sphere, I would expect to see this work. But it's going to happen that the volume of a sphere simply shows up sometimes in some of our integrals. And if you remember that it's 4/3 pi times the radius cubed, you can use that fact. And you can just say, hey, the volume of a sphere is this, and plug in. And that saves you a little bit of time so that you don't have to work through the integral. Now, again, I don't recommend that you just sit down and make flashcards and memorize that, but I do recommend that you make an effort to familiarize yourself with that. Maybe derive it a couple of times, and just be on the lookout for it so that it's something that you hopefully will accidentally memorize by the end of the semester.